Alright, the problem of today is square root x. Given a non-negative integer x, compute and return the square root of x. Since the return type is an integer, the decimal digits are truncated and only the integer part of the result is returned. So, for instance, okay, let's see, let's clarify this question. So we have non-negative integer x, that is when we take the square root of it, we just get rid of, truncate the decimal, and then we have, let's say that we have 10. Then the result will be 3 because it is 3 point something. So we will have 3, we will return 3. And also if we have 4, then we just return 2. If it is 0, then we return 0. If it is 1, then we return 1. If it is 99, then we return 9. Because 10, 9 point, it is probably something like 9.9. So we are looking for number just before it's so let's say that we are looking for the result, and then okay, how can we calculate this? So normally the first brute force approach will be to, when we take square roots, if we take a square of 0 to x, and for each one of them we calculate 1, 2, 4, 4, 9, and it goes on like that. And whenever the value I is equal to is greater than x, then return I minus 1 immediately, and then we stop. But this approach will be O of n, because we have to go until x, O of x actually. So this approach will be O of x, but we can find a better way to do this with binary search. We can, for instance, if it is 99, instead of starting from 0 to 1, 2, 3, 4, 5, and then taking a square of those, we can just check 50, and then 50 is 50 times 50, 2500 is higher than 99, so we just go to 25, and then go to 12, and then we just go to 6, and then we just go to 9, and then we just go to 10, and here we just return 9. So to implement this, we need some values first. So we need left and right, the boundaries. So left will be equal to 0, and then right will be equal to x, because we are looking between 0 and x. And we will change the boundary when we iterate, when we continue this loop, where we let's say that we not found equal to true. So if the so we first need the middle point. Middle point is right minus left divided by 2, but we also need to right minus left. It's actually not right minus left. Actually, we just sum it. Right, we sum, we divide by 2. When it is 25, 50, sum divided by 2, right? Yeah, I think so, but yeah. So if the square of mid is equal to x, or if it is greater than x, then what do? We just have to move right pointer to left, right? Because we want to get rid of the half, mid and a half. So right will be equal to mid minus 1, because the mid is not equal, so we just exclude that. So else it can be equal or it can be smaller. When it is smaller, we just left is equal to mid plus 1. And we also have to check here if the mid plus 1, so the condition I'm writing will be checking if the next number here is greater than our current number, then we found our number here. But so yeah, if the next number is, so if you're smaller than x, our mid number is smaller than the square of number mid is smaller than x, and the next number is greater than x, then we found our solution. So we just multiply mid plus 1, and if this is greater than x, then we just not found equal to false, and we return mid. So let's go through an example. We have 99 here. We just calculate the mid, which is 99 divided by 2. Then we have 49, actually. 49. So, yeah, so we have 49. We check 49. It's not okay. We have 24. And then it's greater than the square of 24 is greater than x, and then let's see, left and right. The left plus right, the right will be mid minus 1. Okay, let's see. The right here, the right will be, I'm just gonna write it here. So the right, the left is 0. The right was 99, and then it is now 49. And then we just go in here, and then the right is 48. I'm sorry, 48, yeah. And then we sum 0 and 48, and then divide by 2, and then we have our mid will be equal to 24. Yeah, here. and then we check it is greater than that, and then we mid minus 1 is 23. We add those and wait, 2. This is yeah, the mid is 12. This is 13. Mid minus 1. This we divide it by 2, it is 11. 11 is greater than that. We divide it by 2. We have 5. When it is 5, we just go here and then we increment middle by 1, which was 5 plus 1 is 6. This one was that. So we go back there, we sum these. The 17 divided by 2 will be 8. We have 8 times 8 is smaller, so we come here, we increment by 1. We have 9 here, and then we again take the midpoint, which is actually 10, with between 6 and if we sum 9 and 11, then we have 10, and then we go else, and the 11 times 11 is greater than x, but we are here with 10, so we just return false here. So I think they should work, but the only problem here is that, let me see, we found 6. This is this is 8, and then when it is 8 plus 11 will be 19, and then I make it 9, and then it is 10. So I think this should work. Let's see. What if we have something like 0? Oh, I forgot to add something here. In each case, if x is equal to 0, we return 0. So we don't go in infinite loop. Oops, I forgot to put 0 here. So yeah, if we also put something like 99 here, let's see if it is working. All right, so let's submit it. Yeah, so the runtime is good because we have log n. The memory usage is we don't care about that because we are using yeah, no, we're not using any space. So here what we do is we do binary search on without any data structure on on a number to search the number, just the square root of a number without with truncated result, actually the square root of x without the integer value. So yeah, this was the answer, and the critical part is to think about this because you have to know when to stop. If you are actually looking for a point where the mid plus 1 times mid plus 1 is greater than x, and also uh, the the current mid uh, location or the current mid number is smaller than x. So we have that in this else statement, and we also check the next value square of next value using this if, and then we change this to false so that we get out of this loop, and then we return the mid because we that's the one we found. All right, that was it. So yeah, thank you for watching.